Welcome back. As you can see, I'm in my AWS console, and from this console we will be able to work with our Kubernetes. But before that, I don't want to use any container or Kubernetes service in Amazon. I want to create my own infrastructure. First, as you can see, I'm in North Virginia region, and you can choose whatever you want. I will choose my North California, and then first let's go to Elastic Cloud 2. This is a virtual machine service. Let's click on instances, and I will click on launch instances. First, we need to add the name for our first virtual machine. This will be K8s control. This will be our control plane. Then I will choose Ubuntu server 24.04. Username is Ubuntu. And for the instance type, we need to choose a virtual machine or image instance, T2 medium with 2 CPU and 4 GB of memory. This is a minimum recommendations to use with our cluster, for our cluster, So if you want to run your Kubernetes cluster, this is the minimum that you must have. Let's click on create new pair. I will add a name for my key pair. This will be kp_10, for example, and we will choose .pem format, and it will open with OpenSSH. We downloaded our key pair on my local machine. Then I will edit network settings. This is my default network. I will choose subnet. Let me choose the first subnet. This region has 3 subnets, 1, 2, and 3. And then I will enable auto-assign IP address. And one thing that you must know, that all regions in the AWS have default VPC, default resource group, and that's it. I will now add a name for my new resource group. My new resource group will be, for example, something like K8SHG or something like that. And security group is something like network security group in Azure. But here in security group, you can enable or disable outgoing or inbound or outbound traffic to your virtual machine. Then we need to see what is our inbound security rules, and this will be SSH TCP on port 22, as you already know. I will just copy my name of my security group in this description. This is required. And as I already told you, we will create inbound security group rules. And with this security group, we will protect our virtual machine. This is some kind of firewall. And we will add rules to allow specific rules, of course. Let's click on launch instance machine. And we created our first virtual machine. Let's go to instances. As you can see, this is our T2 medium VM, and it is initializing. Then let's click another launch instance. We will create 2 virtual machines, but this time this will be K8, so it stands for Kubernetes, worker 01 or worker 1-1. Then we will choose another Ubuntu image. Let's choose another Amazon instance, Ubuntu 24.04. I will choose exactly the same size of our virtual machine, T2 medium. Let's use another, let's use an existing key pair, and I will choose exactly the same virtual private cloud. This is our virtual network. And for the availability zone, let's choose our US West 1.2, and we enable auto-assign IP address, and then we will choose our exactly the same security group that we created in previous step. And that's it. Then just let me check my instances. I will now add 2 number of instances because I want to create 2 worker nodes. As you can see, we successfully initialized launch of our instances, and let's go to instances. And as you can see, this is our instances located in US West 1A availability zone, and I will now simply change the name of my instance, add this to be worker number 2, and let me just add this S after 8, so all of our machines have public and private IP address. That is very important, as you can see. And this is what we need to create our cluster, and this is our architecture for now. When I hit refresh button, you can see all our machine is in a running state and it working as expected. But before we install our container runtime, this is our container D. Let's find out what is container D. So I will use this copilot search just to clear some doubt. Container D, as you can see, is an open source container runtime that is responsible for running and managing containers in our host system. You can imagine this container D as a daemon tool for Linux and Windows, and it handles the complete container lifecycle. So you can transfer image and storage to container execution and do some kind of supervision. Just to remind you, container D was originally, as I already told you in some previous chapters, developed by Docker, and later Docker donated container D to the Cloud Native Computing Foundation, or CNCF. And now container D is a key component in the container ecosystem. So I will now go to my notepad. As you can see, I prepared some instructions for this lecture. Let me just copy this address, and first we need to install the prerequisite for this from this link. I will go to this address, and this is our container runtime. As you can see, this is Kubernetes 1.34, and this is the latest version that we need to install. First, we need to enable IPv4 packet forwarding, and we will use these commands. And we need to do on our control plane. Let me connect using instance EC2 connect. So we are connecting to our worker node, to our control plane node, and we successfully establish our connection. And I will run this command, cat command. We will run systemctl parameters required by this setup. Let me copy this command. I will paste it here on our control plane machine, then hit on enter, and then I will run sudo control system, and this will apply system parameters without rebooting our virtual machine. Let me just paste this here and hit on enter. As you can see, we successfully executed this link. And then if you want to verify your net IPv4 address forwarding, you can run this address systemctl net.ipv4.ip _forward, and this is our address. So the result is what we expected. Then if you scroll down, you need to install systemd. You can run systemd right from this Kubernetes official website, you can click on Linux and you can execute this command. But I already have some commands that I use in my AWS course on Udemy, and I will now execute those commands here. Of course, all these notepads will be included in this lecture, so you can install on your own environment. First, we will run this command to install containerd runtime, sudo apt get update and sudo apt install -yes containerd. So we will first update our system and then we will install our containerd runtime on our control plane node. So we are executing our command. Just to remind you, all these instances are in AWS cloud. As you can see, we are updating and installing our containerd. After successfully install containerd, we need to create the necessary configuration file for containerd. So we will run sudo make dir /p, and this is our folder when we want to install this, to create this directory. Then we need to run this containerd config default, and let's run this command. That's it. And the next thing we need to do, if you plan to use this containerd at a runtime for Kubernetes, you need to configure system C group driver for runC. Then let's run this command. And we successfully executed all of our commands. And finally, we need to restart the containerd service running sudo systemctl restart containerd. And that's it. This is how can you install containerd on our control plane. Now, the next thing we need to do is to do exactly the same thing on our worker nodes. So we will connect to our worker node 1 and run all this command again, and exactly the same thing we will do for our worker node 2. Let me check this box, click on connect. We will connect by using EC2 instance connect, click on connect, and let's run all this command again. So you can run this command right from here. I will now run first this enable IPv4 packet forwarding. Paste it here. Then we will run applied systemctl parameters without rebooting. And let's install our containerd. And after that, we will create our necessary configuration file for containerd. And I will execute all of these commands again on our worker node 1 or worker instance 1. That's it. And as I already told you, I plan to use this. So we need to configure our driver for C group. And finally, I will restart our containerd service running this command. Finally, let's go to our worker node 2, connect exactly the same with our EC instance connect. And first we will run our command to enable IPv4 packet forwarding. Then we will apply systemctl parameters without rebooting. And finally, let's install our containerd runtime. Then we will create the necessary configuration file for containerd. Let's paste this command. And finally, let's execute the last three commands. To finish this lecture and to prepare our nodes to run our container. So we successfully executed all commands on all our nodes. Worker node, control plane node, and two worker nodes. Once that you finally install your containerd runtime on all of three instances, we need to run something called kubeadm. So what is a kubeadm? Kubeadm is a tool designed to simplify the process of setting up Kubernetes cluster. It provides a set of commands to bootstrap a minimum viable information. So we can follow this step from our link. This is a Kubernetes docs setup, and I will open this link to installing kubeadm. As you can see, before we begin, you must read this instruction. So 2 GB of RAM per machine and 2 CPUs or more for control planes machine. If you want to run kubeadm, this is the reason we are using this T2 medium machines. This instance type. So let me scroll down to this side, but first we make sure to disable swap first. So we will run sudo swap off to our control plane -a, and swap is off, and of course we will run this command exactly on our worker node 1 and worker node 2. Then let me scroll down for our official website, and this is our swap configuration. As you can see, the default behavior of a kubelet is fail to start if swap memory is detected on a node. So this means that swap should either disabled or turned off. Then we will install kubeadm, kubelet, and kubectl. So as you can see, kubeadm is the command to bootstrap the cluster. Kubelet is the component that runs on all of the machine in your cluster and does things like starting pods and container. And kubectl is the command line utilities to talk to your cluster. And we will run these instructions to install all of these apt packages and necessary repositories. First, we will run sudo apt get update, or run this command. Let me just run this command. And we will run it on our control plane. Then we will download the public signing key for Kubernetes package repositories. The same key is used for all the repositories. So let's copy the whole command and paste it in our control plane. Then we will run the next command to add the appropriate Kubernetes apt repository. We will do, and this will override an existing configuration in our etc apt sources directory. Just follow the instructions and you will be fine. So in the moment when this video will be available to you, maybe there will be Kubernetes 1.35 or something else. Just change this number to 1.35 and you will be fine. And finally we will run apt package index to install kubelet, kubeadm and kubectl. First we will update our system to download all the necessary packages. And we will run sudo get install kubelet, kubeadm and kubectl. And the last command. That's it. And finally the last command will be sudo apt hold kubelet, kubeadm and kubectl to pin their version. That's it, kubelet set on hold. And finally we will enable kubelet service before running kubeadm with sudo systemctl enable now kubelet, and kubelet will be enabled on our control plane. Exactly the same thing I will do for my worker node 1 and worker node 2, but I will not record this. And that's it. This is how can you install kubeadm on your worker node. The next thing we need to do is to initialize our kubeadm cluster with this command. As you can see, I installed our kubeadm on our worker nodes and we are now good to go. So, as I already told you, our kubelet is ready, and now we need to run sudo kubeadm initialize. So the following command is used to initialize the Kubernetes cluster. We will run sudo kubeadm init pod network cider, and we will add our cider network. Then we need to run this command, and we need to make sure that our kubeadm join command that is given in output, this is required for the next step. We need to copy this. But first let's run this command, and we need to wait. So it is pulling kubeadm config images from well-known repository, and we getting our certificates and key, and after some time we will be finished with initializing our kubeadm. And finally, as you can see, we can join any number of worker nodes by running the following on each as a root: kubeadm join, and we have our token, discovery token certificate, and this is our hash. So I will now copy this command and paste it to my notepad, because this is command that we need to run to join our nodes in our cluster. So let's save this, and we successfully initialized our kubeadm. So you can also run this, but before we use this kube join command, we need to add network plugin. So for the network plugin, you can add a number of network plugins that is available to you, but I want to use Calico plugin, so we will install this and I will show you how. Of course, you can join any number of worker nodes. We have two, but first, as I already told you, we need to run to add some more features to our cluster. Of course, just to remind you, we added our side range, and finally with this network plugin we will be able to talk with our nodes will be able to talk with our in our cluster, of course. So we can use this following link to understand more about pod networking concept, and if we open this in a new tab, we will go to our Kubernetes official page, and you can check all about how can you create a cluster with kubeadm, how can you install network plugin in pod for our pods, and this is all that you need to know. So you can read this. I will leave you this link, and you can simply check all what is a manage node labels, how can you apply your kubelet, how to install a pod network add-on, and so on. There is some commands if you want to use it, but as I already told you, for more information, go just to kubernetes.io and find pod networks. This is how can you set up your network in your cluster. But for now, I will run just this command on my control plane. First, we will create a new directory then we will run sudo to copy this configuration, and finally we will add some permissions to our folder. And let's paste it and copy to our control plane. Paste it here, run on enter. And finally, I will apply the following YAML file to our control node. So you will run kubectl apply -f for force, and this is a raw file for our GitHub, for our Calico. File, and if you open this YAML file, you will see that there is a lot of lines in this YAML file, and thanks to this raw file we will be able to install our plugin, network plugin, to our cluster, onto our pods if you want. So let me just copy this whole command. This will apply the following YAML file on our control node. And if you want to add some other, as you can see, Calico deployment is Calico node created and Calico kube controllers is already created. And if you want to delete this plugin, simply just switch apply with delete and run this command again. kubectl delete/force and this GitHub link. As you can see, this is our command line from earlier. Simply switch delete, apply with delete, and this will uninstall your Calico plugin from your control plane. And I already told you that we can run something like kubectl get all. As you can see, we have our service Kubernetes cluster, we have our cluster IP, it works on port 443 TCP and time when this created. So we can see all our services that we install in our Kubernetes cluster. Of course, we can run kubectl get nodes. As you can see, we have two nodes. We have one node, sorry, and this is our control plane that we created. This is exactly the private IP address of our virtual machine or our instance that our Kubernetes is running. So this is how can you install your network plugin to our control node. And then if I run kubectl get pods, you can see that there is no resources in our default namespace, and we didn't create anything for now. But if I run kubectl get pod / all namespaces, I can list all my namespaces, and all these containers are running in my cluster. So we have kube scheduler, we have kube proxy, kube controller manager IP, as you can see, we have kube API server, we have etcd IP. This is our IP addresses of our system controller or our containers that are running here, and all of this have private IP address of our node. Also there is core DNS, and we have Calico kube controllers that we just installed, and Calico node, of course. So we are ready to move on, and let's see what can we do with join command. And if you remember from our previous chapter, we have our join command that we copied into our notepad. Let's check this command again, and with this kube join command we will now join our node. But first let's type sudo to give us super user permissions, and we will now paste this command to join all our nodes in our cluster. So I will run this command, this sudo join command, in our worker node 1. Let me paste here, and as you can see we have something called, let me paste in worker node 2, we have something called running pre-flight checks. So we need to configure our security group. If you remember, this security group we created when we created our first control plane instances. So we need to specify some rules, and for that we need to go to our console. Let me go to my worker node 1, let's go to networking, and I will now find my security. We will now find our security group that is attached to this virtual machine, and in the inbound rule I will now click on edit inbound rule and click on add rule. I will choose my all traffic. This will be custom source, and I will add our, just let me find what is the, let me open a new tab, and I will go to our VPC. This is virtual private cloud, this is virtual network. Let me go to my VPC and I will copy the side range, IPv4 side range of our VPC. This is our default VPC, and we will paste this as our source. So let's click on Save Rules, and after updating our inbound security group rules, all traffic will be now added here, and we will be able to join this command, as you can see. So the whole traffic is now allowed, and we have joined our worker node 1 and worker node 2 to our cluster. So it's very easy, as you can see. Just need to know what step do you need to run. So in our worker node 1, I will now run kubectl get nodes, and as you can see, this needs to be run on our control plane. So I will have to go to my control plane and run this again. So we will run kubectl. So we are in our control plane. Let me run kubectl get nodes. And as you can see, we have our nodes, worker node 1 and worker node 2, and status is ready, and you can see what is the version and the time when we join these two virtual machine instances to our cluster. But there is something called roles. You can see that we have control plane roles, and this is our control plane role. But how can we edit this role? How can we change these roles? Yes, we can do it by running a label command. So let's try to run this label command, and you will see that roles will be added once that we run this command. So with the join command, just to remind you, we successfully joined our two virtual machines to our cluster, or to our pods to our cluster. So now we have one machine that is control plane and two virtual machine that is, or two pods that is running as worker nodes. So our cluster is complete. But before we continue, as I already mentioned, we need to add something called labels to change the roles of our instances. We can do this by running a few simple commands, and if you follow these steps, this set of chapters in sequence, you will be able to do this on your machine. So first I will run kubectl label node, and I will copy private IP address of our worker node 1. Let me copy this, paste it here, and we can run node dot, let me first click on space, node dot role dot kubernetes dot io slash worker equal, and we need to add our name of our node worker 1. This is k8s dash worker dash 1. Just let me check if we are doing. Let's go to our instances. K8s dash worker dash 1. This is fine, and let's hit on enter. As you can see, node IP is labeled. Exactly the same command we will do for our worker node 2, but we need to add the private IP address of our worker node 2. So kubectl label node, we need to change our IP, and this is exactly the same, but we need to change it to 86. So I will type 172.31-21-86, and everything will be the same, but we need to change this worker node 2. And let's hit on enter. Just to check again. And if we hit on enter, we will see that we successfully added label to our second worker node. So we changed this role. As you can see, we successfully labeled our second VM. And finally, in this chapter, I will show you how can we create a simple deployment on our cluster. I created some YAML files. We will use this nginx first. This is our deployment file. If I open it in Notepad, you can see this is our simple deployment file for nginx. We have two replicas. This will be nginx instance, and this will be simple nginx. And if I open another file, this will be service. This is our nginx instance, protocol TCP, port will be 80, and we will now run these two files. So how can we run this? First I will run cat command. We'll use cat command dot we will run this command, and I will now paste this service, this nginx dash service file dot YAML, and I will open this file again. I open it in my Visual Studio Code, but it really doesn't matter. We are using load balancer, just to remind you, as a service, and I will paste this here on our control plane machine, and let me hit on Control Z, so we create this file, and again I will run cat, but let me change this nginx dot deployment file, and I will copy the whole structure of our file, nginx deployment YAML file here, and I will again type Ctrl Z to exit from this file. Now if we run ls, we can see that both of our files are now located in our control plane instance, as you can see. And with a simple command we can execute both of this YAML file with kubectl apply -f for force, and dot, it means it will execute both our YAML files at the same time. And let's hit on enter. As you can see, we successfully created our deployment and our service. As easy as it gets. And now we can check our pods, for example, kubectl command get all, and you can see that we have our pods, we have our service, we have our deployment, and what is our replica set. And all it's running, all is working. You can see that we have cluster IP address and we have load balancer IP address. Our external IP is still pending, but with the help of load balancer, we can run this command. Of course, you can use node port if you want. Just simply change load balancing type to node port and you will get exactly the same thing. And as you already know, we created our Kubernetes cluster from scratch. And this is the whole process of how can you create your cluster on AWS instance and how can you run a simple nginx deployment. If I run kubectl get all -o wide, you can see more granular information about our pods, service, deployment, replica sets, and so on. So everything is working, everything is fine. You can see for pod nginx deployment, we have two containers. Both these containers run on worker node 1 and worker node 2. You can see by running by specified our API address. As you can see, if we run kubectl get pods, you can see that nginx deployment is running. One container is running on our first worker node and the second one is running on our second worker node. If we run, for example, kubectl get pods, you will see that we have this node IP address, and this is the private IP address of worker node 1, and the second one is private IP address of worker node 2, and the both nginx deployment is running on our instances. That's it. Thank you for watching. And we can run again some more commands if we want, like kubectl get service or get svc, and you can see that we have two services. First is cluster IP and the second one is our nginx service. It is load balancer service. It is working as expected on port 80, but for the external IP it's still pending. We need to specify this external IP address, and you can continue working on this, but the whole meaning of this set of chapters was just to show you how can you create your Kubernetes cluster from scratch, how can you then do some basic deployment, and that's it. Thank you for watching, and I will see you in the next class. And finally, we finish all that I want to show you, and I will now turn off all these windows and I will select all my nodes and simply go to instance state and click on terminate or delete this virtual machine. So after you finish with working in any environment in the cloud, simply delete all that you have built, the whole infrastructure. In this case, I have 3 virtual machines that I created, and I will now delete all my virtual machine. You can also check these graphics in monitoring section to see all recommendations or CPU utilizations, networking and activity that is going on your instances. So we have terminated our virtual machine and we are good to go, and that's it. I hope this was helpful, and now you have more knowledge about Kubernetes. Don't forget to delete your security group, of course, and you can do this after you delete your virtual machines. Now it's time to go and learn about Azure Cloud. Thank you for watching.